Mr. Peldon, this is Math 155. This is Chapter 3, Section 2 on Logarithms. This is Part 2 of the video, the characteristics of logs and graphing them. So what you'll see is these are the stated properties of a logarithm. Very similar properties to the exponential function because it's the inverse essentially. And what you'll see is the properties are basically switched all the way through. And if you look at the graphs, they are basically flipped because they are reciprocals of each other. Not reciprocals, inverses of each other anyways, as we saw in the algebra part in part 1. So they are very similar graphs, just flipped on the y equals x axes because in fact they are inverses of each other. So let's do a few graphs. So we'll do an example of a standard log base 2, which should be the inverse of base 2 exponential function, which we did prior in section 1. So this is in function format. We want to write this in log equation format, which is y equals log base 2 of x, which I don't really want to plug in x and get y. You could. You would be decimal values. It'd be painful. I want to transform that like we did in section 1 to the exponential format. So the base of the log is 2, so that's the base of the exponent. So 2 to the y equals x is the exponential format if I flip it over. Okay, we use our standard graphing techniques of intercepts. By definition, an x-intercept y is 0, and by definition, a y-intercept x is 0. And domain range, vertical asymptotes we'll do afterwards. So if I look at this formula, or equation rather, I would rather plug in y than x. That seems a heck of a lot easier. So I'm going to plug in -2, -1, 0, 1, 2. So this is the flipped method versus what we did with exponential equations. So 2 to the -2 is 1/4. 2 to the -1 is 1/2. So I get 1/4, 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is clearly 4. So if I graph that, at 1/4 I'm at -2. At 1/2 I'm at -1. At 1 I'm at 0. At 2 I'm at 1. And at 4, 1, 2, 3, 4, I'm at 2. So what's happening here is we get a graph like this, which is the flipped graph of the exponential equation, which would be y equals 2 to the x, which would be its inverse. Okay, so you can clearly see this is growth, because if you go left to right, this is growth. It's going up, and it's log base 2. The 2 is greater than 1, thus it's growth. So if I do my intercepts, if I plug in 0 for y, I get 1, which is one of the points on the graph. However, if I plug in 0 for x for the y-intercept, is it possible to get 0? 2 to what power gives me 0? Is that possible? No, that is not possible. Okay. Vertical asymptotes, well, we clearly have one. X equals 0 is the invisible line you're not going to cross, right? All the values in that line are x equals 0. The y value changes. It's a constant vertical equation. Well, how do I get that? Well, you clearly see from the table it goes 1/2, 1/4, and the next one's 1/8, then it's 1/16, then it's 1/32. You can't get to 0. It's impossible. Horizontal asymptote, there is clearly none because it goes forever up and forever down. So for left to right domain, I'm going towards 0, but I can't get there. But I am going to infinity to the right. And up and down are clearly going forever. Okay, pause the video. And I'm sorry, we have one more example on the next page, page 10. Okay, so this time it's log base 1/2. So if I rewrite that as an equation, I get y equals log base 1/2 of x. But I really don't want to write a table with plugging in x and getting y. That would be decimal values. So I'm going to rewrite that in exponential format, which is 1/2 base of the log is base of the exponent to the y equals x, because it's easier to do it this way because I can plug in y's and get much easier values. So 1/2 to the -2 is 2 over 1 to the 2, which is 2 squared and 1 squared for 4. If I plug in -1, all I get is just 2. Anything to the 0 power is 1. 1/2 to the first power is a half. And lastly, 1/2 to the second power is 1 squared and 2 squared, which is a fourth. So this is the same table as the prior problem, except flipped. So at 4, I'm at -2. At 2, I'm at -1. At 1, I'm at 0. At 1/2, I'm at 1. And at 1/4, I'm at 2. So you can clearly see this is decay going left to right as you read a book. And 1/2 is less than 1 but greater than 0. So therefore, they also indicate this is a decay problem. Okay, X-intercept by definition has a 0 for y. So if I plugged in 0 for y, 1/2 to the 0 power is 1, which is one of our values in the table. That is true. However, next one. X-intercept by definition, y-intercept, x is 0. So 1/2 to the y equals 0. What y value gets you 0? That's not possible. There's nothing you can plug in, positive, negative, or fraction, that will give you 0. Vertical asymptotes and horizontal. Clearly it goes for up and down. It goes forever, so there is no horizontal. But vertical, I have a wall right here at x equals 0. As you can clearly see from the table, it's going 1/2, 1/4, then 1/8, then 1/16. I can't get any farther to the left. I'm blocked. So I can try to get to 0, but I won't get there. But I'm going to the positive end. So for range, it's up and down forever. There's no limitation there. All right, pause the video. Try the 2 student problems. All right, student problems. So I rewrite the logarithm base 3. That's going to be 3 to the y equals x. So we want to plug in y values. So if I plug in -2, I get 1/9, I get 1/3, I get 1, I get 3, and I get 9. So we'll graph those. At 1/9, I'm at -2. At 1/3, I'm at -1. I'm at 1, 0. 3, 1, and 9, 2. Okay, so my x-intercept, if I plug in 0 for y, I get 1. If I plug in 0 for x, there's no possible solution for that. And 1, 0 was a table value. X equals 0 is the vertical asymptote, because you can clearly see from our table it goes 1/3, 1/9, 1/27, 1/81. We cannot get to 0 for x. There is not applicable, no horizontal. So my domain is 0 to infinity. My range is -infinity to infinity, because I can go up and down forever. Second student problem. Second student problem, if we rewrite it, we get y equals, I'm sorry, that's wrong. We get 1/3 to the y equals x, and we rewrite the problem. Okay, so plug in our values, -2, -1, 0, 1, 2. So we plug in -2, we get 9. Plug in -1, we get 3. Plug in 0, we get 1. We get 1/3 and 1/9. So it's the flipped table from before. So we have 9, -2. We have 3, -1. We have 1, 0. 1/3, 1. And 1/9, 2. So we can clearly see this is decay, because as you move across left to right, my art skills aren't that good. I missed a couple points there. 1/3 is less than 1 but greater than 0, so clearly it's decay. And if you look at the graph left to right, as you read a book, that's also decay. So x-intercepts, if I plug in 0 for y, I get 1, which is a table value. If you plug in 0 for x, that is not possible. Vertical asymptote is x equals 0. And there is no horizontal. So I can go from 0 to infinity for the domain, and the range I can go up and down forever. Okay, and that is the end of part 2.